From KUNC and the NPR network, this is In The NoCo. I'm Erin O'Toole. Looking beneath the largest mass of ice on Earth to make predictions about climate change. Rick Aster, who leads the Department of Geosciences at Colorado State University, recently published findings from a unique study. Rick is a seismologist, so he and his team looked and listened underneath the icy surface of Antarctica. And they discovered something fascinating. The rock beneath Antarctica's ice sheets actually rises and sinks under the weight of the glaciers. And that geologic movement will affect how much sea level rises as the planet warms in the decades ahead. The question is, by how much? So how did Rick and the team use underground images and sound to learn about the forces shaping our planet? Well, he joins us now to offer some answers. Rick, welcome to In The NoCo.
Thank you, Erin.
You have referred to Antarctic ice as kind of the cork in the bottle that helps hold back glaciers. Before we talk about the latest research, could you explain why it's so critical for someone sitting here in Colorado to try to understand what's happening in this very remote, very frozen continent?
Certainly. Well, although Antarctica is, of course, very geographically remote, there is, first of all, a whole lot of ice piled up on the continent. It's been snowing there nonstop in the interior of Antarctica for something like 30 million years. So there's the greatest store of fresh water and ice in the world in Antarctica. As that ice melts under the influence of global warming, it raises sea level everywhere in the world to a certain extent. And so it's very important to understand in the context of future climate what is going to happen to all that ice and how quickly it's going to melt and raise our global sea levels.
Well, I certainly can understand why researchers would study these massive Antarctic ice sheets to understand how fast melting is happening. What made you want to look under the ice at the rock below?
Yes, these ice sheets are so massive. They're really gigantic geological formations of frozen water, and they're so heavy that they interact quite strongly with the continent underneath them. So to understand how the ice sheet interacts with the solid Earth and how that affects the way ice will flow and melt in the future, we had to look underneath and study the geology underneath the ice sheet. And in particular, see how quickly that land will uplift as the ice sheet loses mass. So as ice melts, it gets lighter.
Okay. And
the Earth, at long time scales of decades to centuries to millennia, is kind of like a sponge or a foam mattress. The ice sheet's so massive, it actually depresses the continent by hundreds of meters. And as the ice mass reduces, that springs back.
Okay. Yeah. Foam mattress. That's a great visual. But help me understand what this looks like or how this process works. How does the uplift of the solid Earth help slow down the melting ice or restrain it?
As the solid Earth uplifts, it presses against the bottom of the glacier and restrains it. It restrains it by keeping the ocean from penetrating underneath the ice sheet. It also restricts it by basically pushing up against it and raising it slightly so it's at higher elevation.
So it keeps the ice sheet a little bit colder, and it keeps it more of it from being in the water where it's more prone to melting.
That's right. And it also presses ridges and other geographic features against the bottom of the glacier that provide additional friction and keep the ice from flowing as rapidly into the ocean.
Rick says all of this could mean one of two things. If humans are able to cut their carbon emissions and slow down the process that warms the ocean, then the flex happening beneath Antarctica will help stabilize the melting glaciers there. But if the Earth continues to warm quickly, the rock beneath Antarctica cannot flex and shift upward quickly enough. And that could cause a more rapid sea level rise of something like 6 to 10 feet over the next century.
The short story is that it's an unstable situation. So once the West Antarctic ice sheet starts to melt by being exposed to a warming ocean, there is a concern that it could actually waste away by breaking off larger icebergs and through increased melt at its base much faster than other ice in Antarctica. And what our study does is it looks at the effect of the solid Earth and how that ultimately can restrain this process to some extent. And it turns out that West Antarctica, where we were doing our study, is one of the squishiest places on the continent anywhere on Earth. So that is actually good news in terms of the solid Earth, being our ally.
It sounds like there's a caveat to that, though.
Yeah, there is a caveat, and the caveat is that for this process to really assist us and give us more time to get greenhouse gases and global warming under control, the ice sheet can't melt too quickly. If the ice sheet melts too quickly, then even in this West Antarctica squishy continent situation, it doesn't rise fast enough to really restrain the process. And in that case, the ice sheet will retreat and raise global sea level, regardless of what the solid Earth is doing.
Rick, how surprising are these latest findings to you? I'm curious if this was what you expected to learn when you began.
Well, we hypothesized that this might be the case, but until we actually went down and made the measurements in Antarctica, no one knew exactly what the solid Earth was doing or would be likely to do in the future. I would say that it's pleasantly surprising to me that this effect can actually slow the retreat of ice if we give it a chance. So that was a pleasant surprise at the end of this long study.
Speaking of long studies, you've spent many, many seasons in Antarctica studying glaciers and land masses and melting ice. What is it like to live and work there for weeks at a time?
Well, it's the remotest place anywhere on Earth. In some respects, the weather can be horrific. The weather can keep you from getting any work done for weeks or months. On the other hand, it's spectacularly beautiful and unique to be down there and see this vast expanse of ice. And also to realize that, in a geologic sense, this ice can disappear rather quickly. I mean, it's amazing to stand on top of a glacier and see nothing but flat white all the way to the horizon and realize that in decades to only a century or so, this could look completely different.
Well, before I let you go, I want to listen to the sound that ice makes. Because you are a seismologist who analyzes data from things moving around underground. What do you hear when you listen to these sounds?
Well, seismic signals are basically a form of sound that travels through the solid Earth. And sometimes, it's actually useful to convert some of these seismic signals into sound and listen to them and try to perhaps gain a bit more intuition using our human capabilities in analyzing sound.
Well, I'm curious if you ever just take those recordings home and, put them on the stereo, help you go to sleep.
Well, we listened to some of them. No one's actually made an album yet of seismic sounds.
I sense an opportunity here.
There may be an opportunity, it's true.
Rick Aster is a professor of geophysics at Colorado State University. Thank you so much for joining us to talk about this.
My pleasure, Erin.
If you want to learn more, we'll drop some links to the study in our show notes and at KUNC.org. And that's it for us today on In The NoCo. I'm Erin O'Toole. Thanks so much for listening.